Hey guys, this video is for the lab covalent compounds modeling, and this video is really a supplement to help go over some of the examples and kind of better explain what you need to be doing for this assignment. And what you should really do to start is to read through these introductions, answer the pre-lab questions, and go over these definitions. That is probably going to help you the most. And then if you are still confused, you can watch this video or rewatch it to see how we get the first few examples done. For this, so we're going to assume with the procedure that you read through the first page, answered the pre-lab questions, and read the definitions. Okay, so we are going to start by looking at number 3, where we draw the dot diagram for covalent bonding. So the assignment is all going to be completed at this table below. Now the first two are done for you. You can see water, H2O, on the first row, and then carbon dioxide on the second row. Okay. The first thing you need to do for all of these compounds is to draw the Lewis dot diagrams. And for covalent compounds, we want to draw circles around the electrons to show a covalent bond being formed. Right? So if we look at water, for instance, we can see oxygen has 6 electrons, 2, 3, 4, 5, 6. Hydrogen always starts with 1. And so there are 2 hydrogens, and oxygen is going to share one of its electron with one of hydrogen's electrons to form a covalent bond, which we can see here, right, as a covalent bond. Okay. Again, you're going to start drawing the Lewis dot diagrams. So for the next one, oxygen difluoride, you want oxygen in the middle, and then the fluoride are going to be on the sides. For the Lewis dot diagrams, remember you have to look at the periodic table, realize what column it's in, and that's how many valence electrons it has. Oxygen is in the 6th column, so it's going to have 6 valence electrons. Fluorine is in the 7th column and has 7 valence electrons. Right? So when you want to draw a circle or covalent bond, you want to just use a different one. We're going to draw a circle around basically all of the atoms that will be in it. Okay. And if we want to kind of make that a little more circular, there we go. It would look something like that. Now let's go back to water and carbon dioxide. So now that you have the dot diagrams drawn, we want to be able to answer these questions over here. Okay, and if we go to the directions up top, we take a look at number 6. Look at the compound and count how many lone pairs are on the central atom for this compound. Okay. To do this also, we are going to need to open up the PhET simulation. So if you click on that link and open it in Safari, it'll take you to this website. Go ahead and open it up. We are going to click on Model. And this is just showing an example molecule. We're going to hit this yellow Remove All button. And we are going to create water molecules. So if we go back to our assignment, so we need to count how many lone pairs are on the central atom. So drawing the Lewis dot diagram correctly is imperative in doing this assignment correctly. And if we take a look at water, we can see that how many lone pairs it has. This is 1 lone pair. This is a second lone pair. So underneath number of lone pairs, you would write 2. Then on the simulation, you can go here and make sure it's on model. You're going to add 2 lone pairs by just tapping on the lone pair box on the right-hand side. Okay. Next, we are going to determine, count how many atoms, if we look at letter B, count how many atoms your central atom is connected to and how many bonds are between each of those atoms. So if we go back to water, oxygen is single bonded to 2 hydrogen atoms, right? We have 1 bond here and one bond here. 2 electrons equals 1 covalent bond, right? They are sharing electrons. So number of bonds present in the molecule, you're going to write that here. And then go back to the diagram. And this time you're going to add 2 bonds, single bonds. Right? So go and tap on the single bonds. And this is our water molecule. You can then take a picture of it, and that is going to go into the final picture or picture of model on the left-hand side here. One last thing, it says to write in the bond angle. You might be wondering how you can do that. It's very simple. You just go back to the simulation and say show bond angles. So here we have 109.5, and no matter how you move it, it's going to always be at 109.5. So you'd go back and fill that in here. Now that's how you do water. There are going to be some instances where you have to do a double bond. So if we look at carbon dioxide, for example, carbon has 4 valence electrons, right? Here, 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 and here. Oxygen has 6. Both of them want to get to 8 total valence electrons. So carbon is going to form 2 double bonds with each oxygen. Right? So if we just look at 1 oxygen and 1 carbon, we can see there's 1, 2, 3, 4 electrons being shared between 1 oxygen and 1 carbon. That is a double bond. And there's 2 single bonds next to the other oxygen as well. You can make this in the simulation to show it, but also if you pay attention, we can see, oh, there's no lone pairs. So no lone pairs, that's going to equal a very linear molecule that we see in this diagram on the left. So start by drawing the dot diagrams for each one. That'll help you answer the lone pair column as well as the number of bonds present column. And then you're going to create that in the simulation to get the picture as well as the bond angle. If you have any questions, please let me know. Hope this was helpful.